Hello and welcome to today's episode on quantitative glottal area waveform. The problem with every kind of analysis is to define what you want to measure. But once you have defined it, you have 183 parameters quantitatively, which is a big step forward. When glottal analysis tools came out on the market, we were fascinated with all of the possibilities, and certainly we used these measurements before and after in each client. The research is developing quickly, and we are on our way to the next area, which is optical coherence tomography, among others. To offer these analyses to the engineers that make the optical coherence tomography is of great value, and we are happy to be able to. In this video, we show you how the calculations are made automatically when you mark the desired area. In an older study, we tried to use questionnaires and phonetograms to compare treatment effect of voice disorders. Self-administrated questionnaires is referred to in Phoniatrics 1 2020, page 357, as well as listeners' screening tests on page 356. We have in this paper presented the possibilities for quantitative measurements for the vocal fold movements. We have not found in the literature any evidence-based results of quantitative descriptions of vocal fold movements in randomized controlled trials, specifically Cochrane evidence-based library. The reason why it is so difficult to use quantitative measurements of the vocal folds is that lots of parameters are involved. Some of the parameters involved includes tissue variability referred to by Garcia. Another aspect is that the moderate correlation between high-speed derived parameters and conventional acoustical or aerodynamic parameters. Out of the 11 papers in Cochrane Library for quantitative vocal fold analysis in randomized control trials, only one included relevant quantitative measurements. The reason why new methods are presented in the literature is of course that the techniques for now are not sensitive enough to pathological phonation. On the right is what everybody hopes for in the future, to use artificial intelligence. These authors use a convolutional neural network approach on 13,000 high-speed video frames from 56 healthy and 74 pathological subjects. The authors suggest some gold standards of 4 anatomical landmarks to be used freely for scientific groups. Thank you for watching, and we'll see you in the next one.